Rainbows, they are nature's beautiful spectacle. On Earth we see them after a rain shower. Sunlight bends through water droplets in the air. This creates an arc of colors, but imagine a rainbow in space. This is not a fantasy. It's real on a planet far, far away. This planet is WASP 121b. It shows us that the universe is full of surprises. Now this space rainbow is not like the ones we see on Earth. It doesn't appear after rain. On WASP 121b, metals like iron and magnesium exist as vapor in the atmosphere. The intense heat of the star interacts with these metallic vapors. This creates the space rainbow. WASP 121b is a planet of extremes. It's what astronomers call a hot Jupiter. This gas giant is about 1.8 times the size of Jupiter. It's also much, much hotter. The planet lies incredibly close to its star, WASP 121. This star is about 850 light-years away from us. WASP 121b races around its star in just 1.3 days. The planet's upper atmosphere can reach a staggering 4,600 degrees Fahrenheit. This extreme heat is crucial in understanding the space rainbow. How does this space rainbow actually form? It's all about light and its interaction with matter. On Earth, rainbows form when sunlight passes through water droplets. These droplets act like tiny prisms. They split the sunlight into its different colors. On WASP 121b, the process is similar but with a twist. Instead of water, it's the metallic vapors in the planet's atmosphere that interact with light. The intense heat from the star excites these metal atoms. They absorb and re-emit light at specific wavelengths. Each metal has a unique fingerprint of colors it emits. This creates a breathtaking spectacle, a swirling, shifting rainbow unlike anything we see on Earth. The colors are likely much more vivid and intense, a testament to the extreme conditions on this distant world. Now, how did we capture this cosmic light show? Enter the Hubble Space Telescope. Hubble is uniquely equipped to observe distant objects in great detail. To study WASP 121b, Hubble used a technique called spectroscopy. It's like passing light through a prism to reveal its different colors. Hubble captured the light from WASP 121b as it passed through its atmosphere. By analyzing the spectrum of this light, scientists could identify the fingerprints of different metals present. Hubble's observations confirm the presence of iron and magnesium in WASP 121b's atmosphere. These metals, heated to extreme temperatures, were interacting with the star's light to create the space rainbow. The discovery of the space rainbow on WASP 121b is not just a pretty picture. It's a major breakthrough in exoplanet research. By studying the light from this space rainbow, we can learn a lot about WASP 121b's atmosphere. What is it made of? How hot is it? These insights are crucial for understanding how planets form and evolve. They also give us clues about the conditions needed for life to exist elsewhere in the universe. The space rainbow on WASP 121b is a reminder that we are just beginning to scratch the surface of what's out there. This discovery fuels our curiosity and pushes us to explore the vast expanse of space.